Hi students, I'm Tanveer Malik. Today we will start unit number 13 and this is the third class about this unit. Unit 13 is about optics. In first class, I have told you what is optics. Optics is that branch of physics in which we discuss properties of light, practical use of light, all those instruments in which we use light. First of all, we have discussed about reflection. Then we have discussed about refraction. In refraction, we have discussed about when ray of light enters from one medium into other medium, it changes its path. Change in path is called refraction. Look at this picture. In this picture, laser light is entering from water, but it does not go to the air. It bounces back in the water. But in refraction, we have discussed about ray of light enter from one medium into other medium, it changes its path. But here, ray of light, which goes from water, it does not go to air. It bounces back in same medium. This phenomena, this is called total internal reflection. So today we will start total internal reflection. This is the laser light. This laser light is going from water, but it bounces back in water. It does not go to the air. This is called total internal reflection. So we will discuss total internal reflection by taking a glass. It is filled with water and this is the source of light. When ray of light enters from water to air, it will show refraction. This is the incident ray. This is the reflected ray. When it enters from water to air, refraction is shown by the ray. But in this case, when we measure angle of incidence and angle of refraction, angle of incidence is smaller, refraction is larger, since it bends away from the normal. If I increase the angle of incidence, now this is the incident ray, this is the refracted ray, but angle of incidence is increased. Angle of refraction will also increase. If I increase more angle of incidence, angle of refraction become 90 degree. This angle of incidence, for which angle of refraction is 90 degree, this is called critical angle. So critical angle is angle of incidence in a denser medium, for which angle of refraction become 90 degree. This angle of incidence is called critical angle. When a ray of light traveling in a denser medium enters in a rare medium means less denser, whose density is less, it bends away from the normal. If the angle of incidence increases, angle of refraction also increases. For a particular value of angle of incidence, angle of refraction becomes 90 degree. The angle of incidence that causes the refracted ray in the rare medium to bend through 90 degree is called critical angle. So when refracted ray becomes parallel to the water, parallel to the other medium, angle of refraction becomes 90 degree and that angle of incidence is called critical angle. This is critical angle, angle of incidence, for which angle of refraction is 90 degree. This incidence angle is called critical angle. So angle of incidence for which angle of refraction is 90 degree. This angle, this one, this angle is called critical angle. When I increase the angle of incidence from critical angle, what will happen? When I increase the angle of incidence, then angle of refraction become greater than 90 degree. When ray of light bends 90 degree greater than, then it will bounce back in the same medium. Now, this ray of light will bounce back in the same medium. This is called total internal reflection. When I measure angle of incidence, then it will be equal to angle of reflection, which is the laws of reflection. In laws of reflection, angle of incidence are equal to angle of the reflection. Both angles are equal. So total internal reflection is when angle of incidence become larger than the critical angle, no refraction occur. Entire light is reflected back to the denser medium. This is known as total internal reflection. Total internal reflection by laser light. Now I will show you the total internal reflection when a laser light enters in a medium and that light will bounce back in the same medium. It will not go to the next medium. This is the glass. Ray of light is entering and all rays of light bounce back in the same medium. This is called total internal reflection. Quick view. This is first ray of light. It shows refraction. When I increases the angle of incidence, angle of refraction become 90 degree. When I increase the angle of incidence from critical angle, all ray of light bounce back in the same medium, which is called total internal reflection. Conditions for total internal reflection. There are two conditions for total internal reflection. Number one, ray of light should enter from more denser medium to less denser medium. That means ray of light should enter from denser medium to rare medium. That means ray of light should enter from water to air, from glass to air, from diamond to air. Then total internal reflection will occur. Otherwise, total internal reflection will not occur. If a ray of light enter from air to water, then no total internal reflection. But when a ray of light enter from water to air, then total internal reflection will occur. Second condition, angle of incidence should be greater than critical angle. Angle of incidence should be greater than critical angle, then total internal reflection will occur. Otherwise, total internal reflection will not occur. Applications of total internal reflection in daily life. It is used in binoculars. It is used in optical fibers. Total internal reflection is used in periscope. This is the periscope. How total internal reflection occur in periscope? This is all rays of light are totally reflected back. An observer who is in the submarine can see the objects which are on the surface of the water. Any activity which is occurring on the surface of water, observer inside the submarine can see all these activities. This is binoculars, total internal reflection, ray of light, totally internally reflected by these prisms, and observer can see the objects. This is the optical fiber, ray of light, bend by using these optical fibers. How rays of light are bent? By using these optical fibers. This is the optical fiber. Optical fiber consists of hair-sized thread of glass or plastic through which light can travel. Size of optical fiber is just like hair. Construction. It consists of two layers. One layer has relatively high refractive index and other layer has relatively low refractive index. So that first condition of total internal reflection is satisfied. This is the optical fiber. This is the internal layer which is called core, and this is the outer layer which is called cladding. Refractive index of core is greater than cladding. So when rays of light enter in core greater than critical angle of the glass, that is 42 degree, then there will be no refraction. All rays of light will be totally internally reflected at each point. In this way, rays of light can bend and all rays of light will emerge from this path. Otherwise, rays of light always travel in a straight line. When object is placed in their path, then shadow is formed. Why shadows form? Rays of light travel in a straight line. When they strike the object, these rays of light will be blocked by the object and its shadows form on the back side. But in this way, we can bend rays of light. By bending these rays of light, we are able to see those places which are not possible seen by direct light. For example, when a doctor wants to see your throat, he uses the optical fiber. He will bend the rays of light. He will put a pipe which is made up of optical fiber. He will illuminate your throat and check the infection in the throat. Similarly, when he wants to check your stomach, there is pain in stomach, he will use the optical fiber, and that optical fiber is called endoscopy. And that optical fiber specifically which is used for stomach, that is called gastroscope. It is made up of optical fiber. At one end camera is fitted and doctor is able to see the stomach in inner side of the stomach. Otherwise direct rays of light cannot enter in the stomach. So by using optical fiber we can bend rays of light. Light enters from one end of the core, strike the core cladding boundary at an angle of incidence greater than the critical angle. In this way, rays of light can travel many kilometers with a small loss of energy. Applications of optical fibers. Fibers can be used under sea communication. Optical fibers are used in military applications. Optical fibers are used in public utility organizations like railway, TV transmission, etc. Optical fibers are used in LAN system of offices, internal plants, and colleges. Optical fibers are used in telecommunication, such as voice telephone, video phones. We use optical fibers. For net communication, we use optical fiber. So in all these fields, optical fibers are used. Now we will check examination style question about this topic. First question is, refractive index of water is 1.3. Calculate the critical angle. Refractive index is given. You have to find the critical angle. What is the relationship between refractive index and critical angle? First, we will write that relationship. And this relationship between critical angle and refractive index is, that is n equal to 1 over sine c. This is the relationship. N equal to 1 over sine c, where n is refractive index and c is the critical angle. So refractive index is given 1.33 equal to 1 over sine c. You have to find the critical angle. That means you have to find the c. So sine c will be equal to sine c equal to 1 over 1.33 or c equal to sine inverse 1 over 1.33. By using calculator, you can find easily critical angle. So this is the examination style question. In this question, you have to find the critical angle and relationship between refractive index and critical angle n equal to 1 over sine c. Next question. Next question is, you have to draw the rays of light inside a optical fiber. Figure shows ray of light traveling within an optical fiber. Complete the path of ray of light to the left hand end of the optical fiber. You have to show the path of ray of light inside the optical fiber. Just you have to draw the rays of light. So this is the total internal reflection will occur. This one. Next is this one. Next is this one. These are the optical fiber. Path of ray of light inside the optical fiber. But you have to put the arrows on these rays of light since you have to show the reflection. This one, this one, this one. But remember this, whenever you want to draw, you have to draw first perpendicular here, so that angle of incidence must be equal to angle of reflection. Then you have to draw the perpendicular here. Be careful while drawing a perpendicular. Angle of incidence and reflection must be equal. Similarly, you have to draw the perpendicular here. Angle of incidence must be equal to angle of reflection. This is the path of ray of light you will show on diagram. Second, name the process taking place at X. At X, what is the process? That is total internal reflection. So at X, total internal reflection is occurring. So you will write only total internal reflection. This is the process which is occurring.